Hi, everyone. I hope everyone has enjoyed the morning session, and I'm going to kick off the afternoon session. Thanks, everyone, for being here. Today, I will talk about towards building safe and secure agentic AI. So, year 2025 was termed the year of agents, and this year, we continue to see further explosive growth of agents. And on one hand, we want to continue to enjoy the great benefits brought by these frontier AI capabilities and agentic AI. On the other hand, we also need to pay attention to a broad spectrum of different types of AI risks. And also, in particular, I want to stress that as we deploy AI in the real world, it's important to consider the presence of attackers for a number of reasons. First, history has shown that attackers always follow the footsteps of new technology development, or sometimes even leads it. And also this time, the stake is even higher with AI. As AI controls more and more systems, attackers will have higher and higher incentives to compromise them. And also as AI becomes more and more capable, the consequence of misuse by attackers will also become more and more severe. And hence, it's really important to consider agentic AI in the adversarial setting. And in particular, the overall goal we are trying to achieve here is to advance safe and secure AI innovation to ensure its potential benefits are responsibly realized and widely shared. In order to achieve this goal, we need to develop different types of technical and also social technical solutions to build safe and secure agentic AI. And in particular, this is a large domain, and we need to actually divide the problems into different categories. So the first part I will talk about is on building secure agentic AI to protect our agentic AI systems from malicious attacks from attackers. And second, I will talk about how we can then, on the other side, mitigate misuse. In particular, as agentic AI capabilities continue to increase, we need to be able to mitigate misuse by attackers. And in particular, I will focus on the impact of frontier AI in the landscape of cybersecurity. So first, let's talk about building secure agentic AI. Agentic AI systems, they can be very powerful and very dynamic. These systems, they use, for example, large language models for reasoning, planning, and figuring out what actions to take, use different tools and so on, and then they allow agents to interact with the environment, to perceive from the environment, and also take actions in the environment. And when we talk about safety and security of agentic AI systems, this actually is much more complex when in the past we only talked about AI safety and security at the model level itself. At the model level, you give it an input, a prompt, you get an output. But with the agentic AI systems, the agents can take rich actions, can have a lot of privileges, and the consequences of attack and misbehaviors can be much more severe. So to learn more information about AI safety and security at the model level, I encourage you to watch my iClear keynote last year. But given interest of time, for the rest of this talk, I will focus on safety and security issues of agentic AI at the overall agentic AI system level. When we talk about agentic AI, we are not talking about just one single type of agents. Actually, there is a broad design space. In our recent paper overviewing the attack and defense landscape of agentic AI systems, we also outline the overall design space of agentic AI along multiple dimensions as listed here. And the point I want to emphasize here is that along each dimension, as we increase the agent flexibility along each of these dimensions, including the input trust level, the to-use workflow, and so on, for the agents, we are also simultaneously increasing the attack surface. And overall, again, in our overview paper, overviewing the whole landscape of attack and defense space for agentic AI, we also identify diverse attack factors and the different types of security risks in the agentic AI space. And you can check out paper for more details. And this also is not just theoretical. In fact, together with the rise of agentic AI, we're also seeing real-world attacks on agents that's rising fast. For example, Cloud Hub for OpenCloud already had a significant fraction of its skills that are actually malicious skills, and we see actually a number of real-world incidents attacks on agents, and it's rising fast. And hence, what I want to emphasize here is that as we increase in agent capability, autonomy, and the set of privileges that agents have, it's absolutely critical that we need to have stronger security guarantees and to ensure a set of different types of security goals, including confidentiality, integrity, availability, and also agentic contextual security and privacy to ensure that agents' actions are aligned with users' intent. In order to achieve this, we need to develop new solutions for building secure agentic AI systems. And here I will talk about two technologies for two main stages of the agentic AI system development lifecycle. The first one is on evaluation and risk assessment, and the second one is on defenses. So in order to build secure agentic AI systems, we first need to be able to do rigorous evaluation and risk assessment so that we can actually understand the different types of risks and different potential attacks on any given agentic AI systems. So my group and with collaborators, we have had long journeys in this direction, and we have been among the earliest to develop, for example, the first comprehensive evaluation framework for the trustworthiness of large language models, for multi-model models, for video models, and also for overall agentic systems. And many of these papers have won Best Paper Awards and so on. And here also is an overview of how we actually think about the overall design space of automatic red teaming for agentic AI. For automatic red teaming for agentic AI, essentially we can think about the system as an optimization loop for automatic attack generation, where we can have these generators that uses different algorithms, including machine learning models and so on, to automatically generate attack candidates. And then these attack candidates are then launched in the environments where the agent is interacting, and then getting feedback, and then the feedback can be used then further to update essentially the generator for these attack candidates. And this can be essentially an automatic feedback loop using different methods to optimize, to generate more effective attack candidates. So the different algorithms for this automatic optimization loop can include, for example, search-based, and also, for example, evolution algorithms, genetic algorithms, and also gradient-based, and also, for example, reinforcement learning-based, and so on. And also this overall automatic red teaming framework can be agentic itself. So essentially, we can build this automatic red teaming agents to actually do automatic red teaming on a target agentic AI system. And this is just a quick overview of the different types of automatic red teaming agents and also frameworks that we have built using the different algorithms that I just mentioned for agentic AI. And also recently, together with other collaborators, we have developed this unified platform for agent red teaming called Decoding Trust for Agents platform, which has a large number of simulating environments, allows agents to the target agents to run in the simulating environment, and using this automated red teaming agents that I mentioned to automatically then generate attack candidates and continue to optimize it and so on as well. And with that, I also want to want to mention our most recent work called Super Red. The goal of Super Red is actually about developing an open ecosystem for this type of automatic red teaming so that we can bring the community together to build the best automatic red teaming framework and system so that we can overall together help improve the resilience of agentic AI systems. So the Super Red is designed as an open source framework that you can run, that's modularized, so you can bring in different attack algorithms, you can bring in different evaluation benchmarks and plug in different types of agent environments and so on. So everything's modularized. So, and also with also fine-grained controlled modularized threat model as well. And Super Red allows you to run any attacker against any AI systems with any threat model. And you can find out more information on the Super Red website. And currently, it already comes in with 35 modules to run today. And as the community contributes and plug in new attack algorithms, new evaluation benchmarks, and new environments, this will build the flywheel to have the community together to build this really powerful open ecosystem for automated red teaming. So we welcome everyone to check it out and contribute. And with the system, you also get detailed runtime, for example, observability, transparent insights, and dashboards, and so on. And it's really easy to install, so really encourage the audience to go check it out. So that's on evaluation. Another important part, of course, is on actually building the AI defense itself. And given the complexity of the issue, there's no single silver bullet for building effective defense. Instead, we need to deploy defense in depth and also deploy and adopt best practice for security, such as least privilege, privilege separation, and safe by design and secure by design to ensure that we, in the end, hopefully we can actually get properly secure systems. And again, in our overview paper, we actually list out close to 20 different types of defense mechanisms that you can use to build as a layered defense. And also here's one example of our recent work called Progent, which is the first programmable privilege control and guardrail for agents with contextual security, where we allow the guardrail to also automatically generate dynamic security policies to dynamically reduce the agent's privilege to achieve least privilege with the contextual security. So with that, that's the first part, building secure agentic AI to protect the agentic AI systems from malicious attacks. Now let me quickly talk about the second part, which is how we can actually mitigate misuse, and in particular, in the space of cybersecurity. So again, as I mentioned, there's a broad spectrum of different types of AI risks. But for me personally, I do strongly believe that cybersecurity is one of the biggest AI risk domains. And this is also why my group will have been among the earliest to actually working to investigate the impact of frontier AI in the landscape of cybersecurity, and also with our work demonstrating the increased risk in the space. So the key question here is, how will frontier AI change the landscape of cybersecurity, especially given that AI as a dual-use technology can help both the attacker side and defender side? And in order to answer this question, we need to actually do detailed analysis through the complex kill chain for different stages of cyber attacks and also for defenses. And in order to achieve this, my group with our collaborators, we have developed a leading benchmarks that has been used by essentially all frontier AI labs on evaluating frontier AI capabilities in cybersecurity that actually covers across the vulnerability lifecycle, including vulnerability discovery, validation, doing exploit generation, and also patching. And with our work at CyberGym, which is a benchmark containing large-scale, widely distributed open source software, we show that frontier AI is capability in cybersecurity is increasing drastically. And also, right, within recent cloud mythos and Project Glasswing also further demonstrated the capabilities of frontier AI capabilities in cyber. And also with the recent exploit gym, also showing that the frontier AI now can also automatically generate exploits, and these exploits can even bypass existing standard security mechanisms. And also, as the many of you may have heard about the recent incidents from OpenAI Hugging Face. The agent actually, while trying to solve the exploit gym benchmark, it actually broke out of the isolation sandbox from OpenAI's environment, and then actually in the end did very sophisticated attacks to actually in the end was able to break into a Hugging Face infrastructure as well. So all this illustrates that now with the increased frontier AI capabilities, the agents now have really strong capabilities in cyber. The agents, this was not even a misuse. It was not a malicious attacker trying to use agents to compromise another system. The agents actually did this on its own. So first of all, this told us that now with the agent's capabilities, even the evaluation infrastructure itself can now are now becoming part of the attack surface. And also this really is a wake-up call showing the power and the potential risk these agent capability can bring to the world. In order to address all these issues, so first we have launched a Frontier AI Cybersecurity Observatory, bring the community together to do continuous monitoring of the frontier AI capabilities increase in cybersecurity. And also, a bigger question is, what can we do? Especially given that AI as a dual-use technology, it can help both attacker side and defender side. And also the challenge here is that coding capabilities and the cyber capabilities are two sides of the same coin. And what's even worse is that we call this the equivalence class problem, is that the same capabilities that can help defenders, essentially in our paper, we show that they can also be used by attackers in the corresponding stage for attacks. And furthermore, there is natural asymmetry between defense and offense. And for example, attackers only need to find one successful vulnerability and exploit and do a successful attack where to succeed, where defenders need to defend against all attacks. And also in our paper, we also show a number of other natural asymmetries between attackers and defenders, showing that unfortunately, due to this natural asymmetry, in the near term, AI is going to help attackers more than defenders. So the question is, what can we do to shift AI to help defenders more than attackers? Throughout the history of cyber security community, and also including my own work in the last 2 to 3 decades, we have gone through 3 different paradigms for building defenses. The first one is reactive defense, where defenders develop attack detection and blocking mechanisms, and also other mitigation mechanisms after attacks has happened. Unfortunately, with this defense paradigm, my belief is that, and also our analysis shows that attackers can still benefit more from AI than defenders. And the second paradigm is proactive defense through bug finding, where in this case, the defenders can use AI to try to find bugs in code first and then hope to fix them before attackers. However, in this case, again, attacker also can be at an advantage in the sense that attackers only need to find one successful attack. So we really hope that with AI, it can help us to achieve the third paradigm in a more effective way, which is proactive defense through security by construction. Using this approach, we architect and build probably secure programs and systems, in contrast to bug finding and attack defense and reactive attack detection and reactive defense mechanisms. And so through program verification, using formal verification, we hope that we can actually build systems with probably secure guarantees that can completely eliminate entire classes of vulnerabilities and so on. So this ultimately will put defenders in an advantage to attackers. And in fact, we have already entered the era of formally verified systems with many formally verified systems, including microkernels, compilers, and so on. But however, it's been labor-intensive to actually do the proof engineering for the systems, and hence they have not been widely used. And my group has been among the earliest, also with our collaborators, to develop deep learning methods for theorem proving. And I strongly believe that now we are reaching an inflection point. Using frontier AI, we can further enhance formal mathematical reasoning and automate theorem proving. We hope that using this approach, instead of just generating code, we can actually generate provably secure code where we combine the program generation, program synthesis with program verification. And towards this goal, we also have developed the current leading benchmarks for verifiable code generation, including Verna and Vero, which now allows us to evaluate AI capabilities for verifying codes at a large-scale repository level. And we hope that with the community together, we can make rapid progress in this space. And we can now finally use AI to help shift the dynamics, to help AI help defenders more than attackers. So with that, I want to conclude my talk. And I want to just briefly mention that besides this work, we also are developing various work on open ecosystem for agent evaluation, including Agents Last Exam, a benchmark for evaluating agents' capabilities in real-world, economically valuable, long-horizon tasks over 55 different sectors, and also agent beats for building new standards for open, standardized, reproducible agent evaluation. And you can learn more at later today's workshop on future of agent evaluation. With that, thanks everyone.